Okay. So in the last class, torque we were discussing, no? Huh?
Yes, sir.
Right. Next one, angular momentum. Alright. So that is angular momentum. So do you know what is linear momentum? So angular momentum represented with L.
Momentum mass into velocity.
So the momentum of a body in rotational motion is nothing but angular momentum. The momentum of a body so in rotational motion is angular momentum. Is angular. So let's see, we'll find the angular momentum. So we can also write the product of linear momentum and position vector is nothing but an angular momentum. Let's see. Suppose this is the axis of rotation. This is the axis of rotation. And one part rotating like this. So in a circular manner, this is the rotating. One particle is rotating like this. Like this. So its radius is r. Its radius is r, position vector. So this is the axis of rotation. It is rotating like this. And what is the radius? Suppose the radius is r. R vector. So its position vector. So if we consider particle is rotating, no? So if it is rotating, then the tangent will be this is a tangent, means there is a linear velocity, right? Linear velocity v. So it is also a vector quantity, no? Velocity is also a vector quantity. Vector quantity. And here, so this is theta. So this position vector and velocity vector makes an angle theta. Makes an angle. And in this one, what is the torque? So torque will be tau this one only, no? Torque. So here we are applying some force, then this. So here this particle of mass is m. Now torque is acting y-axis, z-axis. So we consider one particle of mass. Particle is rotating with sorry. This This particle is rotating in a circular orbit of radius vector r, and this makes angle theta, and its arc will be in z direction. So in this case, the angular momentum can be written as angular momentum so that is L cap equals to r vector cross p vector, because angular momentum is also a vector quantity. L equals to r cross p, and in terms of magnitude, if you write L equals to what we can write, rp sin theta, rp sin theta. So cross product, no, that's sin theta. So here this is the angular momentum. So torque we got, torque is nothing but r cross f, and angular momentum is nothing but r cross p. Angular momentum is r cross p. Understood? So and we can also define, but we know that what is one, but so p equals to m into v, na? P equals to m into v. So if theta equals to 0, theta equals 0, angular momentum will be 0, and if theta equals to 90 degree, means position vector and vector velocity vector both are perpendicular to each other. In that case, angular momentum will be L equals to into P, and L equals to, but P equals to what? mv. So therefore L equals to what you will get, m into v into r. So L equals to m into v into r, mvr. Remember what this is. Okay. So and SI units of angular momentum will be SI units. SI units. So kg meter square per second are the SI units, and dimension formula you will get. So dimensions m L square t power minus 1. ಅರ್ಥ ಆಯ್ತಾ? ರೊಟೇಷನ್ ಮೋಷನ್ ಅಲ್ಲಿ ಇರೋಂತ ಮೂಮೆಂಟಮ್ ನ rotational angular momentum ಅಂತೀವಿ, and angular momentum will be r cross p. So this is the equation. Friends, are you there?
Yes, sir.
ಯಾಕೆಲ್ಲ ಸೈಲೆಂಟ್ ಆಗಿದ್ದೀರಾ, ಅದು ಕೇಳಿ. ನಾವು ಎಲ್ಲ ಸ್ಟಾರ್ಟ್ ಆಗಿವಮ್ಮ. Go for next one.
Sir, R into P na P into R.
R cross P.
Sir, ಕೆಳಗಡೆ ಬರಲ್ವಾ ಡೈರೆಕ್ಷನ್ R ಕ್ರಾಸ್ P? ನೆಗೆಟಿವ್ Z ಆಕ್ಸಿಸ್ ಬರಲ್ವಾ?
ಪಾಸಿಟಿವ್ Z ಆಕ್ಸಿಸ್. ಕ್ಲಾಕ್ ವೈಸ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲ, ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲ. ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಡೈರೆಕ್ಷನ್ ಪಾಸಿಟಿವ್.
Yes sir, correct.
Sir, once again, can you explain the diagram?
See, so consider one circular path. The object is so rotating in a circular path. 1 minute. Sir, 245 ಹಾಕ್ರಿ. ಸೊ ಇಲ್ಲ ಅಂದ್ರೆ 5 ಗಂಟೆ ಮೇಲೆ ಹಾಕ್ರಿ. 245 ಹಾಕಿರೋ ಮೀಟ್ರು. ಓ ಹೌದಾ, ಬೇಡ ಹಂಗಾರೆ 5 ಹಾಕ್ರಿ. So ಇದು rotational axis. One particle of its mass rotating in anti-clockwise direction. So and its radius. So this is the radius. So the radius of the circular track will be r. And what is the velocity? It is rotating in a circular path. What is the velocity? The velocity always is tangent to that particular point. Suppose if you want to find the velocity at this point, so just draw one tangent here. So this is the velocity.
Yes, sir.
Understood? So if an object is rotating and it is a position vector, usually torque what we can write? So torque tau equals to r cross f. We will write now r cross f, torque tau. And this is the direction c, this is the r, and force is in the direction of the velocity only. So therefore torque will be along z axis. Even angular momentum is also in the z axis, z direction. Even angular, understood?
Yes, sir.
Understood? Shall I go for next one? Oh, ಯಾರು ಡೌಟ್ ಕೇಳಿದ್ರಲ್ಲ ಯಾರು ಅವ್ರಿಗೆ ಕೇಳ್ತೀನಿ ನಾನು. Right. So relation between angular momentum and torque. So angular momentum and torque. What is the relation between force and linear momentum? Relation between force and linear
Can you go to previous page, sir?
relation between force and linear momentum. ಏನು? Anybody?
Change in rate of change of linear momentum is equal to 4.
F equals to dp by dt.
Yes, sir.
Same that only. Let's see. Finished, ba? Shall I go for next one?
Yes.
So we know that momentum L equals to R cross P. R cross P. So differentiate with this one. So differentiate with respect to t, with respect to time. So if you differentiate with respect to time, then that equation will be what? So d by dt of L equals to d by dt of R cross P. R cross P you will get. So do you know the product rule? Differentiation product rule.
Yes, sir.
What is the product rule?
D by dt of u into v is equal to u dv by dt plus v du by dt.
So this is a formula. So here u is nothing but a r, v is nothing but a p. According to that, you can expand that one. So dl by dt equals to, expand this one. So u is r, r cross into r cross dp cross by dt plus dr cross by dt na, shall we write?
Yes, sir.
So dv by plus v dt. So according to this one. So but we know that, see here dr by dt, dp by dt equals to what? Dp by dt, rate of change of momentum. Linear momentum is nothing but a force.
Yes, sir.
So therefore dp by dt equals to what we can write? Force. Next to linear momentum p equals to what? m
Yes, sir.
and rate of change of position vector equals to what?
Velocity.
Velocity. Substitute all this in the other equation. So if we substitute dl by dt equals to r cross, can we write f1
Yes, sir.
plus, so m into v cross v vector cross, again dr by dt equals to what? V only na? V.
Yes, sir.
So if you observe one thing here, see v cross v will be what?
0.
0. Yes, dl by v cross b means same direction, therefore theta will be 0, sin 0 will be 0, 0 into 0, 0 will get. Therefore dl by dt equals to r cross f again. So what is r cross f? R cross f,
Torque.
torque. So therefore torque tau. So here v cross v equals to 0 and torque tau equals to what? R cross f. R cross f. So this is a torque tau. So finally we'll get torque tau equals to rate of change of angular momentum. Rate of angular momentum. Hope you understand.
Yes,
Yes,
sir.
sir.
And see, linear momentum we discuss, that is force F equals to what? dP by dt na? dP by
Yes,
dt.
sir.
See, force F equals to dP by dt. Force is nothing but a torque in rotational motion, and P is nothing but a L rotational motion. Therefore, tau equals to dl by dt. Torque tau is equivalent to force, and dl by dt is equivalent to dP by dt. It is linear and it is rotational. So we can write the rate of change of linear momentum, angular momentum is equal to the applied torque. Applied torque. Suppose if this equation, if you apply for system of particles also, so for system of particles, only single particle if you consider, for system of particles also you will get same equation. So here the system of particles, this tau is nothing but an external torque bar. So this torque is nothing but a what? External torque. The internal torque won't affect the torque. So that equals to dl by dt. Individual we can write, no need to write this. So this is a relation between torque and angular momentum. Finished?
1 minute, sir.
1 minute.
Okay, sir.
Hmm.
Sir, 1 minute, sir, 1 minute.
ಆಯ್ತಾ? ಆಯ್ತಾ?
Aye,
Yes,
sir.
sir.
Next law of angular momentum. Conservation of angular momentum. So conservation of angular momentum is linear momentum. See, so we know that F equals to what? F external equals to dP by dt. So if F external equals to 0, then dP by dt equals to 0, then P equals to constant.
Yes, sir.
P equals to constant. Here P is what? Linear momentum. Linear momentum remains a constant. In the similar way, so we are writing for, so but instead of force here, torque will be 0. Torque will be 0. So write down. If the net external torque, net external torque acting on a system is 0, torque acting on a system is 0, is 0. The total angular momentum so remains constant. Remains constant. So here, that is, we know that what is torque relation between torque external equals to what? dl by dt
dl by
usually.
dt.
So dl by dt, but torque equals to 0, therefore dt equals to 0. Hence torque external equals to 0. So it is 0. Then L equals to what?
Constant.
L equals to constant. Mohita,
Yes, sir. Done.
next one.
1 minute, sir. Done, sir.
Next one. Equilibrium. So equilibrium of A, which is what? So when we say that the body is equilibrium,
When the sum of the forces acting on the body is 0.
sum of the forces. So that is translated in equilibrium. Even if it is in rotational equilibrium, on the other side rotational motion is linear motion is so just as in the switch rest. So if you switch rest, that means we can't say only force. So if the force net force acting on a particle is 0, we can say it is equilibrium. But suppose you have a forces are acting on the body, then it starts rotating. So in such cases, it is a rotation motion. So here the rotation motion should be rotation motion also not reversal. So such case we call it as equilibrium. Rotation into translate equilibrium. So both forces are zero, then we call it as equilibrium. Okay. So see, if forces are zero, then linear momentum will be constant.
Yes, sir.
So right. If net external force and torque and external torque, external torque is zero. And then the body is in equilibrium. Okay, understood? The body. So the first one is F is equal to 0. So F external force which is equal to 0 for total on the rigid body. So on the rigid body external force equal to means nothing, even the force due to each particle is also come up with a 0. Second condition, tau external also 0. So if these two satisfies, then we say that it is equilibrium. Understood? All the directions, the force is along x axis, along y axis, along z axis is also same.
Yes, sir, understood.
So this is called equilibrium of the rigid body. Next one, so principle of movement. Principle of movement for a river. So remember this principle of movement ಬ್ಯಾಲೆನ್ಸಿಂಗ್ ಚಿಕ್ಕ ಮಕ್ಕಳು ಆಡ್ಕೊಂತಾರಲ್ಲ ಆ ಕಡೆ ಒಬ್ರು ಕಡೆ ಈ ಕಡೆ ಒಬ್ರು ಹೊತ್ಕೊಂಡು ನೀನ್ ಜಾಸ್ತಿ ವೇಟ್ ಇದೆಯಾ ನಾನ್ ಜಾಸ್ತಿ ವೇಟ್ ಇದೀನಿ
Seesaw.
Seesaw.
ಸೀಸಾನ
Oh, sir.
ಸೀಸಾ ಸೊ that so we'll consider that one. So exactly at midpoint. So here one force, here one force, and point exactly at midpoint one. What we call so So this is balanced. This is seesaw is balanced on this at this particular position, and at this position means the normal is acting in upward direction, a normal force. Yes, a normal force. And suppose this is a force F1 and this is force F2. So force F2. We know that if F1 is greater than F2, then so it is coming left side, and if it is a right side is more, then it will go downside at the right side. So let us consider this distance is D1 and this distance is D2. This distance is D2. So actually this principle used in general applications also, in daily applications also, where means see ಕೆಲಸ ಮಾಡ್ಬೇಕಾದ್ರೆ ಯಾರನ್ನ ಅದನ್ನ ಕೆಲಸ ಮಾಡ್ತಿರ್ತಾರಲ್ಲ, ಸೊ ವೆಯ್ಟ್ ಲಿಫ್ಟ್ ಮಾಡೋದು ಅದು ಇದು ಅಂತ ಇದನ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡಿರ್ತೀನಿ ನಮ್ಮ ಮೆನಿ ಪೀಪಲ್. ಸೊ ಜಸ್ಟ್ ಸಿ, ದಿಸ್ ಇಸ್ one object, this is on the surface of the earth. Now we have to lift this one. So for lifting this one, what we will do, we can't lift with hands, so we'll consider one a strong iron rod. Do you know?
We lift with crane, sir.
No, we are not human beings are doing this one. A strong iron rod will take and we'll insert at this point and we'll start pressing like this. Yes or no? So if you apply
Yes,
force
sir.
like this, then it is moving up now.
Yes.
So observe ಮಾಡಿದ್ದೀರಾ ಈ ತರ.
Yes, sir.
And so here it is, everything is mud. That's why in some cases what we'll do, we'll keep some strong objects or stone here. Here we'll keep stone. Yes, and we'll start pressing it again. We'll keeping on
Is
stone.
it because that part should not move?
Huh?
Is it because that part should not move?
So we'll keep one stone here and again. Yes, sir. Observe ಮಾಡಿದ್ದೀರಾ?
Yes, sir.
Yes, sir.
So here, like this, if we do, this is called load arm. What we call load arm. This is load arm. No, here. This is load where we are applying the force. This is load, and this point is called effort. So if you apply more force, and effort will be same. So see, on this one we can write here also. Suppose if you apply the force in F2 direction, and F1 will be load, and F1 will be effort, and F2 will be load. According to this, see, one sentence can define that is mechanical advantage. So mechanical advantage. Problem solve ಮಾಡಿ mechanical advantage. So mechanical advantage ಅಂದ್ರೆ so it's nothing but a mechanical advantage equals to F1 by F2 equals to C1 by D2. F1 by F2 equals to so D2 by DT. DT by DT. F1 by F2 equals to what? D2 by DT. That is, in other words, we can say here F1 into D1. So equilibrium negative. Suppose this object is in equilibrium. Equilibrium net force will be 0, no? So net force will be 0. Net force will be 0 means normal force equals to F1 plus F2. Okay? Understood?
If the rod is long, very long, then little force is applied to the lift now.
Yeah. So that one is usually between changing stepney, that is the vehicle success or stepney. Right?
Yes, sir.
So that's the kind of so it is very long, small, short we take the force easily. Suppose it's a long current, we can easily move it. Remember? So
right?
yes.
That is just as considered.
Yeah. So equilibrium. Now normal force is yes. This is translated equilibrium. Translated equilibrium. So in mechanical equilibrium, so what you get must be say force per perpendicular. Force per perpendicular what P1 S force per perpendicular, which must be equal to F or D. Right? Force per perpendicular distance. So this is equal to force on the force equals to means another force by P का force is equal as I equilibrium and this is rotational equilibrium. From this, so F1 by F2 equals to what? So F1 by F2 equals to you can write D2 by D1. D2 by D1. So this is called mechanical advantage. So mechanical advantage. Mechanical advantage is even if from the same force out of force, just fixing the depends. We can lift the object. So we can take an example. You are longer leg we are considering, no? So if we increase the D2, so D2 increase body, so we can increase the force F1. Yes, so force F1, so we increase the force F1. So F1 equals to what? So F2 D2 by D1. See, I am not increasing the force F2. I am not increasing. Same force I am applying. But what I am changing? Just distances I am changing. Distances. So by changing the distance, I can increase the force on F1. Force F1 you can increase. No? So that is nothing but a mechanical advantage. ಅರ್ಥ ಆಯ್ತಾ? Hello.
If the distance D2 is increased and F1 is increased, it will still be in equilibrium, no sir?
F1 we are not it means same amount of how much if you increase the D2, how much force is increased by increasing of D2. If same amount of force F1 is increased there, then it will be equilibrium only. Right. So this is mechanical advantage. Next one. So that we can discuss in the next class. ಯಾವ ಕ್ಲಾಸ್ ಇದೆಯಲ್ಲ
ಇವಾಗಿಲ್ಲ ಸರ್.
So actually ಇದನ್ನ this we call it as D1 is load or F1 is load. So ಇಲ್ಲಿ ಎಲ್ಲ ಬರೀತೀವಿ ನಾವು ವೇರಿಯೇಬಲ್ಸ್ ಸಿ. So F1 ಏನಂತೀವಿ ಅಂದ್ರೆ ಲೋಡ್ ಅಂತೀವಿ and D1 ನ load R. So F2 na effort D1 D2 na effort. So F1 by F2 equals to D1 by F2.
Where you are applying force, that is effort, no sir. Where you are applying force, that is effort, and where you are getting the result, that is load, no sir.
Same only now I told here.
That previous page, something else example you said, no, that little bit ulta, I think. That rod and rock, that stone lifting and all.
This is here. This is load. Okay. This is effort. Here and we are lifting that object.
Yes sir.
Yes sir, that time you said ulta sir.
Yes sir.
ಓಕೆ ಅಂಡರ್ಸ್ಟುಡ್ ಆ ಫಾರ್ಮುಲಾ ನೆನ್ಪಿಟ್ಕೊಂಡ್ರೆ
ಎಸ್ ಸರ್.
ನಾಳೆ ಕಂಟಿನ್ಯೂ ಮಾಡನ್ರಿ. ಬಾಯ್ ಬಾಯ್, ಟೇಕ್ ಕೇರ್.
ಥ್ಯಾಂಕ್
ಸರಿ,
ಯು ಸರ್.
ಚಾಪ್ಟರ್ ಇನ್ನ ತುಂಬಾ ಉದ್ದ ಇದೆಯಾ?
ಹೂನಪ್ಪ, ತುಂಬಾ ಉದ್ದ ಇದೆ. ಇಂಪಾರ್ಟೆಂಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಹೋಗಿಲ್ಲ ನಾವು, ಆಕ್ಚುಯಲ್ ಕಾನ್ಸೆಪ್ಟ್ಗೆ. ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ.
ಸರ್ ನೆಕ್ಸ್ಟ್ ಡೇ ಸರ್.
ಹಾ ಹೌದು.
ಓಕೆ ಸರ್.
ಬಾಯ್ ಮಾ.
ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ಊಟ ಆಯ್ತಾ?
Bye, sir.
ಊಟ
Thank you,
ಆಯ್ತಪ್ಪ.
sir.